My name is Barbara Melchert and I'm from the Department of Molecular Pharmacology, and this is a recorded class on the novel coronavirus for the course Pathology and Immunology for the first year pharmacy students. Today is March 18th, 2020, and we are in the midst of a novel coronavirus pandemic. So what is this coronavirus? Coronaviruses are zoonotic viruses, meaning they circulate in animals, mostly circulating in bats, and can sometimes mutate and infect humans too. They consist of a single RNA molecule, as can be seen here, covered by a lipid bilayer, which is coated in spike glycoproteins, which give the virus its very distinctive shape. There are versions of the coronavirus circulating in the human population already, and these cause the common cold. But sometimes a novel one makes a jump to humans, and that can be problematic, as is the case now. Here you can see an electron microscopy image of the coronavirus with the specific spikes sticking out. And researchers have estimated that around November 17, 2019, in Wuhan, China, a novel coronavirus infected a human being, and this one turned out to be a bit of a problem. This is not the first time this happened. Coronaviruses circulate in bats, and in 2003 one mutated and infected a civet cat that then made the jump to humans, and in some of the infected people caused a disease called severe acute respiratory syndrome, and therefore the virus was called SARS. More about the clinical characteristics of SARS can be found in one of the other recorded classes. The epidemic with this virus was effectively contained and did not grow out to be such a huge problem as we are facing now. And in 2013, another one transmitted to humans. This one was circulating in camels already for quite some time, but in 2013 made the jump to humans. And since these camels are endemic in the Middle East, was called the Middle East respiratory syndrome. And this one was quite more problematic than SARS because it was more lethal. But fortunately this one was very well contained and didn't spread out too much over the world. The one we are facing now has been called the severe acute respiratory syndrome coronavirus number 2, SARS CoV-2. And the disease it causes is called COVID-19, coronavirus disease 2019. This one jumped to humans probably through an animal called a pangolin. That's a sort of an anteater, but researchers are not quite sure yet. Why and how do we know that this event occurred on November 17th? That is because the viruses that are isolated from humans are sequenced, and their genetic information contains clues as to where they come from. Because every time the virus replicates, there are tiny little mutations in its RNA, and following these mutations can tell you something about where they come from. So researchers estimate that the first virus developed or jumped to humans on November 17th and was mainly present then in the Chinese population. So the purple dots are Chinese populations. And then so there's this line here, and then traveled to the United States, those are the red dots, and then changed a little bit, still in China, and then moved to Australia and some European countries. Then it changed again and infected a lot of people in Europe. And then it changed again. Of course, started again in China, but moved to Europe. And that's the way you can see how each infected person, where the virus is coming from. So it's quite spread over the world now. This is a timeline of what has happened. So on December 31, China alerted the World Health Organization that there were some suspicious pneumonia cases that could mean another virus, coronavirus, like the SARS virus from 2003, was spreading in the country. Then on January 7th, France confirmed its first case. January 11th, China announced the first death. And on January 13th, the WHO reported the first case in Thailand. And the number of cases increased dramatically in China. So on January 23rd, Wuhan went into lockdown to inhibit the spread of the virus. On January 30th, the WHO declared the outbreak in China as a global health emergency. And on February 2nd, the first death was recorded outside China. It was in the Philippines. Then, unfortunately, on February 7th, the Chinese doctor who first alerted the authorities to this novel coronavirus and the world basically died from the virus. Up until then, the virus was known as the Wuhan coronavirus. But the WHO on February 11th decided that the virus should have a different name that wasn't related to its location. So the virus itself was called the SARS CoV-2 virus, and the disease it causes was known as COVID-19. February 14th, Egypt confirmed its first case, being the first country in Africa. And we now know that the WHO has declared the virus as a pandemic, so it's basically spread all over the world. So if you look at these three coronaviruses that have threatened humanity in the past 10 years, then and look at mortality related to age, and you can see that the MERS virus is the most lethal one. As you can see here, it has an average mortality rate of around 30%, especially in older people. The first SARS virus mostly had problems in older people. And this new coronavirus is very much like the first one, except that it appears to be a little bit more lethal to especially older people. So how does this new coronavirus compare to another big killer, which is influenza? Because influenza here in the US infects at least 29 million people, has infected this year, and has caused up until now 16,000 deaths. As of February 24th, there were only 14 diagnosed cases in the US, with 0 people dying. But in China, around February 21st, there were already almost 80,000 reported cases with more than 2,000 deaths. So if you put it in this perspective, it doesn't seem too bad as compared to influenza. But of course, we now know that the virus is very infectious and is spreading all over the world. And especially in Italy, many people are dying from this virus. So another comparison with influenza, which is interesting, because in this graph the novel coronavirus is plotted, the mortality of the novel coronavirus is plotted against age for two types of influenza viruses, normal seasonal influenza virus, but also the Spanish flu that caused so many people to die after the First World War. As you can see here, the seasonal flu doesn't kill many people, except maybe for a slight increase in the elderly. And what was so shocking about the Spanish flu was that it killed many young children. Of course, it killed many old people, as normal flu also does, but there was a peak in young people as well. So people between the ages of 20 and 40 were also dying massively of this virus. If you compare that to the novel coronavirus, there in the younger people it seems to be similar to seasonal flu, but the older you get, higher the chances of dying. Well, the severity of the epidemic also depends on the infectiousness of a virus, and how a virus spreads is defined by its reproduction number, or R0. So if the R0 is 2, it means that every infected person can infect 2 new people, and then you get a sort of a rapid spread of the infection. If the R0 is 1, it means that the infection will propagate in the population, but it will not increase and it will also not decrease. When the R0 is smaller than 1, it means that the infection will die out eventually. So how does this novel coronavirus compare to other viruses that we know? Well, we don't actually know the R0 of the novel coronavirus yet, because we don't know how many people are infected worldwide, because a lot of countries are not testing everybody, and a lot of countries do not have enough tests, and the world is now running out of components of the tests. So history will tell us what the R0 was in the beginning of the epidemic, but for now it's estimated between 2 and 4. If you compare that to, that's higher than the seasonal flu, which the R0 is around between 1 and 1.5. But it's lower than, for instance, measles, which is very infectious, which has an R0 of around 15. And if you compare that to SARS and MERS, both were, so SARS was had around the same R0, but was seems to be more deadly, but I'm not quite sure if that still is true. MERS was far more, or is far more deadly, but had a R0 smaller than 1, and that's why the epidemic could be contained much more easily. So the R0 has a lot of factors that it depends on. One of them being the virulence of the virus of the bacterium. So let's just talk about viruses here. Because the more virulent, so the more disease-inducing a pathogen is, the less chance for transmission, as you can see here. If you become very ill from a virus, then you'll self-isolate, or you will die and you won't have a chance to transmit the disease. Whereas if a virus is less virulent, then you just go on doing your thing and you will infect many people. So for example, Ebola is very virulent, but it kills the host so rapidly that it's difficult for the disease to spread to other hosts. So that's what you usually see. the more deadly a virus is, the smaller R0 will be, because the virus then doesn't have a chance to spread. So another factor that determines R0 is the population. Because a virus needs to infect people, and genetics might play a role there. Some people might not be as susceptible to the virus than other types of people. This is an interesting graph showing the evolution of the COVID-19 cases until March 15th of this year. And what you can see here that for a lot of the European countries, the number of cases increases in a similar rate. But there are some countries that show a very different pattern, just like Singapore, Japan, and South Korea. This could indicate that these people are less susceptible. It could also mean that they have instilled measures to prevent the spread of the disease. So we have no indications that genetics play any role in the susceptibility. That it's too early to tell at this point. But we do know is that Japan and Singapore have been very strict, have been very good at isolating cases and detecting cases and keeping the virus contained, whereas all these European countries were not paying attention basically, and let the spread of the virus through. As you can see here, South Korea in the beginning was similar to European countries, but has ramped up its testing and its isolation of cases, so that's why now the growth is reducing. Same with China, which of course went into lockdown, and you can see that these measures do seem to have effects. That's why now the whole country in Holland is also in lockdown. So this is a more focused graph of some of the European countries, and as you can see here, so this is the date that not all countries start at the same time. So Italy was infected way before these countries were. But once the epidemic starts off, they all sort of go on with the same speed, same number of cases developing. So it sort of seems to suggest that within Europe there aren't that many differences between the people getting the disease. It also means that to inhibit spreading of the disease, you need to take other measures. One of them being, for instance, social distancing. And this can be seen here as being very effective in after the First World War with the Spanish flu. These were the number of cases in 2 American cities, one being Philadelphia, one being St. Louis. This is Philadelphia, this being St. Louis. So both these cities noticed that the number of flu cases were increasing, and St. Louis decided that all big mass gatherings were prohibited to prevent spread of the disease, but Philadelphia allowed a big parade to continue, and that led to a big spike in cases, whereas St. Louis managed to contain the disease pretty well. Here, another example of the fact that social distancing actually works. These are the number of cases in Italy, and green is the city of Lodi, and red is the city of Bergamo. So Lodi decided to lock down the city and isolate everybody on the 24th of February, and this led to a decrease in cases 2 weeks later. And Bergamo, which had a very similar way of development of the disease, did not lock down the city yet, and you can see that the number of cases continue to increase. So Bergamo only decided to lock down the city on March 7th. So we expect that by March 21, their number of new cases will start to diminish as well. So another good way to reduce R0 is vaccination or inducing immunity, and we're going to discuss herd immunity with that. So what is herd immunity? Herd immunity is having many people in the population immune against the disease to prevent spread to non-immunized people. So here's a population of immune naive people, like we were, all of us, because nobody had seen the coronavirus before. And when there are two infected people and all of these people have never seen the virus before, they can all be infected. It means that these two people can easily infect the whole population. Then we go to this situation. All the yellow people have been immunized or got the disease before and are immune. And we again have these two infected people, but because they're surrounded by immune people, it's more difficult for the non-immune people to get infected. So to get to this point, you would need at least 60 or 70% of the people immunized or immune. And since we do not have a vaccine against the coronavirus yet, this means that 60 to 70% of the population should have had the disease to reach this state. Well, if we allow 60 to 70% of the people to become ill now, then we'll have a problem, because many of these people will need hospital care, and we don't have that many beds to take care of all these people. So if we do not do anything at the moment, then there will be this huge increase in number of cases, and we will overwhelm our healthcare system capacity. So that's why the country now is in lockdown, to prevent the rapid spread of the disease. So the number of cases will be more spread out, and we'll still be able to care for everybody when they do get seriously ill. And this has been named Flatten the Curve. So we have this new virus. Nobody has immunity. We don't have vaccinations. So how does your immune system deal with this? To find out, go to the next class, where I'll talk more about how our immune system deals with viruses.